Okay, Algebra 1. We need to talk about functions or key features of a quadratic function. Okay, so let's graph the following lines on the coordinate plane. G of x is x plus 1 and h of x is x minus 3. So to graph x plus 1, so x plus 1 has a y-intercept of 1 and a slope of 1. So like so. So if I were to graph that line, something like this. Okay, if I can make it go, let me adjust it just a little bit. Like so. So this is g of x equals x plus 1. H of x is x minus 3. So x minus 3 has a y-intercept here and the same slope. So if I draw that line, something like that. So this is h of x equals x minus 3. Now, what would it look like if I multiplied the two functions, x plus 1 times x minus 3? So if x is negative 2, okay, so let's look at the x and y values of the different ones. So if I plug in a negative 2 to the first one, so negative 2 plus 1, I get what? Negative 1. Let's do that in, make our color, negative 1. If I plug in a negative 1, I get 0. Plug in a 0, I get 1. Plug in a 1, I get 2. Plug in a 2, I get 3. In the other function, x minus 3, plug in a negative 2, and you get negative 5. Plug in a negative 1, you get negative 4. Plug in a 0, negative 3. Plug in a 1, negative 2. And plug in a 2, you get negative 1. Now, if I multiply these together, so x plus 1 times x plus 3, I am multiplying these numbers, okay? So when x is negative 2, if I multiply the negative 1 and the negative 5, I get 5. Multiply here, I get 0. Multiply here, I get negative 3. Multiply and get negative 4. Multiply and get negative 3. So when I multiply these two lines, I look at the y values I get. And so let's graph those in green. So negative 2, 5. So negative 2, 5 is right there. Negative 1, 0 is right there. 0, negative 3 is right here. 1, negative 4. 1, negative 4 is right there. 2, negative 3 is right here. Let's plug in a 3. If I plugged in a 3, if I plugged in a 3, this would be a 4 and that would be a 0. Multiplying, you would get 0. So I get a 0 right there. So what I see this function doing is something like this. So the green just represents I have multiplied two lines together, okay? So if I actually, and I can do the multiplication there, if I multiply these two functions together, you get x squared minus 3x plus x minus 3. This is x squared minus 2x minus 3. So that's what I just graphed. The graph of this is called a parabola. Okay, so I graphed two lines. We know how to graph those. but the graph of a quadratic is a parabola, and that's what I'm seeing here. So if I look at this, this is the one that I just did. So we just graph this guy. There should be a parentheses here. So the graph of x plus 1, that's this guy, x plus 1. The graph of x minus 3, that's this guy, x minus 3. Now, so g of x, and then the blue was h of x, and then the green is f of x, okay? So what were the x-intercepts of g of x? Where did I cross the x-axis with the red? -1, 0. H of x, where did I cross the x-axis with the blue? At 3, 0. Now look at the green one. Where are its x-intercepts? It has 2. -1, 0. I just stick with the color. -1, 0. And 3, 0. But that should make sense because all the parabola is the multiplication of two lines. Anytime you multiply by 0, you will get 0. So a 0 on the line will also be a 0 on the parabola. So what is the relationship between the two x-intercepts of the parabola and the x, and we'll get that in a moment, axis of symmetry and vertex? The vertex of the parabola is this point right here. Parabola always comes to a point. So this vertex is 1, -4. The other thing we will notice about the parabola, it is symmetric. If I were to draw a line straight through that parabola, what I see on one side mirrors what's happening on the other side. So if you think about it, you go over 1, up 1, over 1, up 1, over 2, up 4, over 2, up 4, okay, over 3, and I go up over 3, up 9, over 3, up 9. So they're matching points. So the equation of this axis of symmetry, the equation of that line right there is x equals 1. What's the relationship between the two x-intercepts and the axis of symmetry? If I look at this one, here's my axis of symmetry. There are my two x-intercepts. Okay, so the axis of symmetry is in the middle of those 2 points. You go 2 to the right to get one x-intercept, 2 to the left to get the other. Now, what we need to do is we need to come up with a pattern for how we graph these things, make this a little bit larger. You want to try to avoid having to plot points every time. Now, the first time I'm going to plot points. So x, and then I'm graphing x squared. So -3, you square it and you get 9. -2, you square it, you get 4. -1, square it, you get 1. 0, 1. And then 1, 1, 2, 4, 3, 9. So let's start with, 0, 0. Let's start with 0, 0. Okay, and then I've got 1, 1. I also have -1, 1. 2, 4, -2, 4. 3, 9, -3, 9. So this parabola looks like this. And the other way I can graph it is like you're squaring a number. So 0, when I get x equals 0, the y is 0 squared. X equal 1, the y is 1 squared. The other thing I notice is that this thing has an axis of symmetry at x equals 0. So once I have a point here, I've got a matching point over here. Now the other thing to try to do is to try to recognize the pattern. This graph starts at 0. Okay. If I go over 1, 1 squared is 1. So my pattern is over 1, up 1. Well, it's going to match on the other side, over 1, up 1. Over 2, square 2, you get 4. So I'm going to have a matching point right there. Over 3, square 3, you get 9. So over 3, 9, you get a matching point. So if you can just sort of memorize the pattern with this guy, starts at the origin, 0, 0. And I'll say over 1, up 1, because you square 1 to get 1. Over 2, up 4, because you square 2 to get 4. That will help you when this thing starts moving around, okay? Let's look at 2x squared. So if I plot points for this guy, x and 2x squared, okay? So if I plug in a 0, I'm going to get a 0. You plug in a 1, you're going to get 2. You plug in a 2, you're going to get 8. Plug in a negative 1, you're going to get 1 times 2. Plug in a negative 2, you're going to get 2 times 4, which is also 8. So 0, 0, 1, 2, 2, 8, and then negative 1, 2, negative 2, 8. So in this one, the pattern was I start at 0. Okay. Now, normally what I said last time, you go over 1, up 1, because you square 1 to get 1. What's different? The other one, it was just square, but this one is multiplied by 2. So instead of going over 1, up 1, I'm going to go over 1, up 2. Okay. Now, there's a matching point right there. Normally, I would go over 2, up 4, because 2 squared is 4. But in this one, instead of going over 2, up 4, that 2 in front means I'm going to go over 2 and up 8. And then there's a matching point right there. If I were to go 3 over 3, normally I go over 3 up 9. This one would go up 18, which is not on my graph. Okay, so there's the pattern for this guy. Looking at this one, negative 2x squared. So if I plot points, plugging in a 0, you get a 0. Plug in a 1, you get negative 2. Plug in a 2, you get negative 2 times 4, you get negative 8. Plug in a negative 1, you're going to get negative 2, and likewise here. And the pattern here, these things start at 0. Normally, I would go over 1, up 1, but multiplying by negative 2, instead of going up 1, I go down 2, over 1, down 2, over 1, down 2. Normally, I would go over 2, up 4. That 4 gets multiplied by negative 2, so it's over 2, down 8, over 2, down 8. So that pattern, if I can recognize that over and over, it's going to help me, okay? The general form for a quadratic and vertex form is given here. F of x is equal to a, x minus p, x minus q. The number in front is my leading coefficient, tells me if this parabola goes up or down. If it's a positive number, then my parabola looks like this. If it's a negative number, my parabola looks like this. Now, where is this thing? Where will the y value be 0? When x is p, this becomes a 0. When x is q, that becomes a 0. So p0 and q0 are my x-intercepts. Now, the axis of symmetry is halfway in the middle of p and q. It's the average of p and q. The vertex always lies, so the vertex always lies on that axis of symmetry. And so the x-coordinate of the vertex is p plus q over 2. And if you plug that in, you will get the y value. The y-intercept is what you always find when you set x equal to 0. So let's graph a few of these. So it needs to be an intercept form, which it is, okay? Now, in this one, a in front is negative 2. This parabola will open down. The x-intercepts, okay? Well, when x is equal to 3, y will be 0. When x is equal to 7, y will be 0. So 3, 0, and 7, 0. The y-intercept. The y-intercept is what you get when x equals 0. So y will be -2 times -3 times -7. So this is what? -42. So 0, -42. That's going to be off of my graph. Okay. The axis of symmetry, this one I can think it's halfway in between these 2 points. Or you could just say P plus Q. So 3 plus 7 over 2, that's 5. So this is the line x equal 5. Now to find the vertex lives somewhere on that line where x is 5. So all I have to do is just plug a 5 back into this original function. So y is equal to -2, x minus 3, x minus 7. Plug in a 5. You get -2, 5 minus 3, 5 minus 7. So this is -2 times 2 times -2, which is 8. So the vertex is the point 5, 8. So the vertex is the point 5, 8, which is right here. Okay. Now if I needed another point, normally this guy is going to go over 1. Remember our pattern. Normally x squared, you go over 1, up 1. This one is going to go over 1, down 2. So there's a point right there. There's another point. So now I got a good way of graphing this guy. Now I could find this point. Remember, normally I would go over 2, up 4. This is going to be over 2, down 8. So over 2, 1, 2, 3, 4, 5, 6, 7, 8. That's correct. The domain of this function, the x values always go from -infinity to infinity for all of these. The range, my y values go from -infinity up to as high as 8. So -infinity to 8. Increasing and decreasing. The concept here is like as you travel from left to right, do your y values go up? So I could mark this point right here and this point right here. As I went from left to right, did the y values get bigger? Answer is yes. This function increases as x goes from -infinity all the way over to 5. Okay, so it increases from -infinity to 5. And then once I get to 5, this thing starts decreasing. It decreases from 5 to infinity as x goes to infinity. So the decrease is 5 to infinity. Increase and decrease always have parentheses, okay? There are no brackets for that one. Because at the point 5, it's not increasing or decreasing, it's setting still, okay? But up to 5, it is increasing, okay? Let's look at this one, graph 2x, x plus 2. Well, to put it in this form, this is f of x equals 2, x minus 0, x plus 2. This guy opens up because the number in front is a 2. The x-intercepts, x minus p, so it's going to have one x-intercept at 0, 0. And x plus 2 is the same as x minus -2. So -2, 0 are my x-intercepts. So 0, 0 and -2, 0. Now, the y-intercept is what you get when x is 0, but I can see when x is 0, I get 0, 0. So that is my y-intercept. The axis of symmetry is the line that is halfway between these 2 points. So that is x equal -1. To find the vertex, I know the vertex has an x value of -1. So I just need to substitute that x value in to the original. What was it? X plus 2? Yep. So if I substitute in a -1, you get 2 times -1 times 1, which is -2. So there's the vertex, -1, -2, right there. This is the point, the line x equals -1. And if I need any extra points to graph, remember the pattern. Normally I go over 1, up 1. This is going over 1, up 2. Instead of going over 2, up 4, I'll go over 2, up 8. So that puts me right here. Once I see that point, there is a matching point right there. So that gives me an added point to make this a little bit more accurate. The domain, answer to all of these, -infinity to infinity. The range, your y values. There are no y values until you get to -2. So the range is -2 to infinity. Increase and decrease. As I start from left to right, it decreases from -infinity until it gets to -1. So -infinity, -1, and then once I get to that spot, it starts increasing. Oh, I did this wrong. It's decreasing, so this is, let's back it up. I always like to do left to right. Left to right, first of all, it's decreasing. From -infinity to -1, it decreases. And then at that point, it starts increasing, okay? This guy opens up or down. It opens down because of the negative in front, okay? The x-intercepts are going to be at -3, 0, and 2, 0. So at -3 and at 2. The y-intercept is what you get when x is 0. So I'm going to get -0 plus 3, 0 minus 2. This is -3 times -2, which is 6. So 0, 6 is my y-intercept. Okay. Now the axis of symmetry is halfway between these 2 points. 1, 2, 3, 4, 5. So 1, 2.5. So right here is the axis of symmetry. And that's x equal -1/2. Now the other way you get that, you just take this p and q and you average them together. -3 plus 2 over 2, -1/2. Okay, so x equal -1/2 is the axis of symmetry. The vertex is what's going to happen when I plug in a -1/2. So f of -1/2 is going to be negative, what is that, 1/2 plus 3, 1/2 minus 2. So that's going to be -3.5 and -1.5. So this is going to be -7/2 and -3/2, which is going to be what, 21 over 4, which 4 goes in there, what, 5 and 1/4. Okay, so the vertex is -1/2, 5 1/4. Did I do that right? Let's see. I don't think that's right. Let's see if I do it again. So 3.5 is 7/2, and -3/2, 24. Wait, what did I do right? So negative, let me try that again. So my function is what? Negative x plus 3, x minus 2, is that right? X plus 3, x minus 2. So yeah, I see the mistake I make. So when you plug in a -1/2, you get negative minus 1/2 plus 3 minus 1/2 minus 2. Okay. So I didn't make these minus. So this is going to be, this is 2.5, and this is what? Minus 2.5. So this is minus 5/2 minus 5/2, which is 25 over 4, which 4 goes into there, what? 6 1/4. So this point is -1/2, 6 1/4. So if I plot that, -1/2, 6 1/4 is somewhere right here. So there's my vertex. There's a matching point right here. So this guy does this. The domain, same for all of these guys. The domain is -infinity to infinity. The range, y values start at -infinity and they go high as 6 1/4. So -infinity to 6 1/4. Increase, decrease. I always just like to look left to right. Left to right, it starts increasing. So it increases from -infinity over to -1/2. So -infinity to -1/2. Once I get there, it starts decreasing from -1/2 to infinity. And that leads us up into the homework for this section. Okay?